G'day, it's Toby Wicks here from High Integrity Systems. Thought I'd knock up this quick video just to explain the interpreter library and how it works, how it hangs together, and what it does and what it doesn't do. Basically, it's a pretty simple language interpreter. It's not a fully fledged language like an object-oriented programming language. It's really just designed as an expression interpreter, so something sort of similar to what you'd find in a formula in Excel. It doesn't go much beyond that. There are some extended things you can do to make it a bit more like a language. You can chain functions together and things like that, but essentially it's designed as a simple sort of single line expression interpreter. There are a few gotchas, I guess. It can be a little bit slow. It is an interpreter. There is no compile checking. It's licensed under Apache License 2. You can grab it on github.com/HiSystemsInterpreter. Feel free to add your own. You can add your own functions and operators to the language, so it's fairly easy to add your bits and pieces that you need to. It's cross-platform. I'm running it on for iPhone at the moment. It should run on any sort of Mono or Windows environment. And if you've got any queries or anything, just email me, toby@hisystems.com.au. High Systems as in High Integrity Systems. So, with that out of the way, let's delve a little bit into what it actually can do. It supports some very basic data types. You've got text, Boolean, numbers, arrays, and date times. Number sort of covers integers and floating point numbers as well. So it's actually internally stored as a decimal. But I think that sort of covers most bases. It's got mathematical operators. You can use plus, minus, divide, multiply. It's got some comparison operators, equal, not equal to, less than, greater than or equal to, less than or equal to, and logical operators, or and end. And as I said before, you can add your own operators if you really wanted to, or just email me and I'm happy to add one in for you if you want. There's also a set of inbuilt functions that you can use too, which at the moment it's got a sum and average function, some other functions as well. But the idea is you can really add your own functions fairly easily, and it's also got variables as well. So in an expression you can define a variable and programmatically set that variable value. So I've got a demo project set up here. I've downloaded the interpreter library from GitHub, and I've just got a console app here ready to demonstrate a few bits and pieces. So let's start with something simple. To begin with, we need to create an engine object. That engine object is the base class, and from that you can then parse expressions. You can add your own functions. So this is the sort of core object that needs to be created. So let's just parse a simple expression. So that will parse the expression. It won't actually execute the expression. That's a second step. So let's execute that expression. Just write that out. So we should expect a value of 2. So let's give that a go. Great, we've got a value of 2. The execute function will return a literal. Now if we know what type that literal is going to be, so we know that it's a number, or we know it's a string, we know it's a date time, we can actually say, well, that this is going to be, we expect it to be of type number. Let's give that a go, and that should essentially turn the same result. But this is more useful if you've incorrectly defined you're expecting a number and it returns a Boolean, or vice versa, it returns a number but we think it's going to be a Boolean, which is incorrect. So this should come up with an error. It really just helps in defining a better error message. So that'll throw an invalid cast exception with a better error message than you would have otherwise. Okay, So moving on to something a little bit more complicated, we can define variables within the expression. So let's define a variable called a and set the value equal to 2 and change this back to number. So we should expect a value of 3. Great, and you can of course define that variable multiple places, and you only need to set that value once, so that should return a value of 4. Great. You can also do operator equality, and that should return a Boolean. So obviously that should return false. Not equal to is less than, greater than, as you'd find in Excel. So it returns true. There's also support for constants, so you can define true. So that should return true. Okay, so moving on, you can also define an array using the array function. So let's define an array 1, 2, 3, and let's sum the values. So that should return 6, but it won't be a Boolean. Oops. Okay. So you can see that it actually gives you a fairly good error message. I think that you can pick up pretty easily what the issue is if you've cast it incorrectly or made a mistake somewhere. Okay, great. Value of 6. There's some other data set functions. I think average is another one. Of course, you can roll your own. It's very simple. There is support for dates too. You can define date literals. So let's just define a date. Just as long as it's formatted within hashes and in year, month, day format. You can do addition. So that should set a value of, there we go, 2nd of January, that's correct. And you can, there's a today function you can use too. Again, you can roll your own if you want to. I'll demonstrate rolling your own functions in a minute anyway. The support for strings, so you can define string concatenation, for example. Let's just turn that off, so that should return value AB. Okay, as a text literal. There's also the an if function as well, so if you want to conditionally display something and return a different value, you can use an if statement. Let's do something a little bit more complicated. Perhaps let's see if let's get this out of the way. So if today is, let's just reorder that to make it a bit clearer. So if today is greater than 2000, which it certainly is, then we should return ABC. Or let's return something a bit more obvious. Today is after 2000, year 2000. Alternatively, we can actually return something you wouldn't expect necessarily. You can actually return a number. So there's no strict type checking that you'd normally find. Okay, there we go. Today is after year 2000, which is great. Let's just switch that around just to prove that we can return a different type if statement. So yeah, we return a value, and that's actually internal, a number, literal. Okay. So there's no limit on those. So there's no limit on the length of the expressions. You can create a very long expression, but sometimes you will want to chain expressions, and I'll show that shortly. But before we do that, I just want to quickly show you how to write a function or add your own function to the library. So let's add a new class. Let's call it my machine name. Let's give it this namespace because don't need that. So basically all you need to do is override the function class. Let's override the two functions that we need. So the name is what will actually be looked for in the expression. So let's call it my machine name. And we know that there shouldn't really be any arguments, so we can assume that the argument count is 0. The arguments variable is actually passed in just so that it will provide a better error message. It's not really used for anything else. So we know that we want to ensure that there's no arguments, and we want to return a value that is their machine name. So let's return a text value, which is system environment dot machine name. Okay, so as simple as that. So we now have this function. We need to register that function to use it in the engine. So we just register the function, my machine name. So let's create an expression that uses that. And execute that. So it will return a string. We can verify that by adding something at the beginning or end. Great, so Win7 is my machine name. So that's a fairly simple function. Alright, so let's hop back into the function. What we might do now is make it a little bit more complicated. We can pass through an argument, for example, that determines the format of the machine name. We might want to suffix it with the DNS name. So let's do that. So we might receive an argument, we might not receive one argument. So it's going to be between 0 and 1. It's the number of arguments that we receive. So ensure argument count is between, minimum is 0, maximum is 1. So if our argument's length equal to 0, then we just return what we were returning before. If the arguments, well, we can assume that will be 1. So let's get the actual argument value. So let's, for example, pass through a format value. So it might be a long or short string. To do that, we just need to get transformed arguments. We know it's of type text. In the arguments list, and it's argument number 1. So if the format is equal to short, let's return what we returned before. Else, if the format is long, let's do something a little bit different. I'm not actually on a domain, so I'll just simulate that. And if we don't receive a correct format argument, we can throw an exception Okay, so I'll breakpoint it so we can step through. Let's run that. So based on what we have in the program at the moment there, so we've got an argument here which is long of type text. So our argument count should be 1. There we go. So argument is long, and there we go. So Windows 7 mydomain.com is my machine name. Let's just check that it works with short. There we go. So Windows 7 is my machine name. Great. And we can optionally include an argument. So functions are fairly flexible. You can add your own arguments, obviously. They can be optional arguments. They can be any type. And all the tools are in the base class basically, so you should be able to pull out the information that you need fairly easily and just focus on the logic of the function. So that's functions. What I thought I'd do quickly now is just do an example of chaining expressions together. So sometimes that might be useful. Basically, the way it works is you can define a variable here in your expression, and that variable can then link to another expression. So we might, for example, do a plus 1, and we might define another expression plus 2. Now our variable a, the value is actually equal to expression 1. So our result should be a plus 1, which is 3, plus 1 is 4, and our result should be 4. Let's give that a go. Great, so that works. So there's no real limit to how many functions you can chain together, and it can be obviously quite complicated, but that allows you to have multiple lines of code and then sort of execute them in sequence in a way, and get around having particularly long expressions as one line. So that's pretty much it. Hopefully that was useful. Let me know if you have any comments or questions. Take it easy. Cheers.